Welcome to Lavanya's computer classes. In this video, I will explain linear search and analysis of linear search. What is the worst case, best case and average case of linear search. So what is a linear search? Linear search means searching an element. Linear search is used for searching an element in the given list. So that is called as linear search. First, for example, if you are taking some elements like this, it is an array representation. So in this we are taking the elements 20, 15, 7, 45, 23. So our next 100. Taking the elements like this. In this I want to search an element. My key element is 23. So I want to search 23 element is in the given list or not. So using linear search you have to searching the element. So how can you search the element? Means this is the array elements. It starts from 0, 1, 2, 3, 4, 5. Totally 6 elements are there. So what is the algorithm for finding element in this? Means if key element. What is key element? Key element is 23. If key equal to a of I, because I value starting from for I equal to 0, I less than n, I plus plus, this is the loop. So if key equal to a of I, then find it is a, then printf, it is a successful search. Otherwise unsuccessful. Like this we can search it. This is the linear search algorithm. Just else, printf, unsuccessful search. Unsuccessful search. So this is a simple algorithm only. So take the elements, loop elements from I value 0 to I less than n and search each and every element with key. Compare the key element is in the first element or not. So for example, what is here? Loop I value starting from 0. What is n here? N equal to 1, 2, 3, 4, 5, 6. N equal to 0. So I value 0 to I less than 5 means 0 to 5. So what is the key element? Key element is 23. So first key element 23. 23 is equal to a of 0. So what is a of 0? A of 0 means 20. So 23 equal to 20. Is it true or not? Means it is false. So then we go for I plus plus. I plus plus means I value is 0. Now it is incremented to 1. A of 1. A of 1 means is coming to here. So what is a of 1? 50. And what is your key element? Key element is 23. 50 is equal to 23? No, this is also wrong. Then again I plus plus. I plus plus means I value is coming to second place. That is 7. So what is your key value? Key value is 23. What is a of 2? This is here a of 2. A of 2 is 7. 23 is equal to 7? No, here also condition is wrong. Then again we go for I plus plus. I plus plus means I value is now 2. Now it is coming to 3. I3 means coming to here. So what is key element is 23. A of 3. What is A of 3 value? Is 45. 23 is equals to 45? No, it is also wrong. So again go for I value I plus plus. I plus plus means I value is 4. That means coming to here. So here what is your key value? Key value is 23. A of 4. A of 4 means it is 23. So 23 is equals to 23. Yes. That means it is a successful search. So like this linear search algorithm is works. So linear search is also known as sequential search. Sequential search means sequentially one after another each element is compared with its key element. Whenever both are same, then immediately we write successful search. Otherwise check it one after another till the last element. At the end of the element list also you are not getting the key element means it is called as unsuccessful search. This is the concept of linear search. Now I will go for analysis of linear search. Linear search means either we explain any analysis is explained with 3 cases. One is the best case, average case, then last one is worst case. In these three cases, we're just analyzing any algorithm. Best case, average case, and then worst case. What is the best case? Best case means it is search key present at the beginning of the list only. Best. If the search element is available in the beginning of the list, that means first element is your key element. Then within first iteration, the first time only we get the successful search. That is called as best case. Best case means in the beginning of the list only we get the successful search. Worst case. What is the worst case means? Worst case is searching a key at the last index. Last index means last element, that means search key is in the last element or totally not find in the list. Either it is a last index or not find. Unsuccessful search, that is also called as worst case. So what is best case means the element is available in the first index only. That means 0th index, first place only we get that element. Worst case means the element is not at all present in the list, or if it is present, it is the last value, last index position in the given list. Average case. Average case means it is between best case and average case. Between best and worst case. That means it is available anywhere. Either not in the first position or not in the last position. It is available between anywhere in the list. That is called as average case. Video I will explain binary search. Binary search with an example. Already in the previous videos I will explain divide and conquer method. So binary search is also an example for one application of divide and conquer method. So first we go for what is binary search. Binary search is a fast searching algorithm with time complexity of O of L log n. So binary search is we have two types of binary search algorithms are there. One is linear search and the second one is binary search. The linear search is also known as sequential search. So linear search is also a good example for searching technique. But in this, if the search element is in the last element, if the which element you want to search, that element is in the last position, then number of iterations are more, number of steps are more. Finding that element, for finding one element, you have to check all the elements. If the size is more, it takes number of iterations. So that is the one disadvantage of linear search. For overcoming the disadvantage, we go for binary search. What is the binary? Binary means 2. Here, all the numbers, the list of elements will be divided into 2 parts. Either we will search the elements either in this side or like this, in this part. So that's why number of iterations are almost all half of it will be reduced. That's why binary search is well suited method for searching an algorithm. So it is a fast searching algorithm. Because why it is fast means because either we can search either left hand side or right hand side depend upon the elements. And it is based on divide and conquer method. Binary search algorithm is a good example for divide and conquer strategy. And here we have to remember one point, that is all data items should be in the order. If you want to search any elements using binary search technique, all the items should be in the order. It is very, very important. So these are the some points in binary search algorithm. Now I will explain the algorithm of binary search algorithm. So algorithm BST, binary search BS, while low less than or equal to high. Here we need low element and also high element. I will explain with example. If the low element is always smaller than or equal to high, then calculate mid. How to calculate mid? Means mid equal to low plus high by 2. After calculating mid, then we need search element. We need mid element and search element. First we calculate mid element, that is low plus high by 2. Then search element. Then compare mid element and search element. If both are same, 3 points we require. First point is middle element and search element both are same. That means then we get it is a successful search and the element is found at middle of the position. Then stop your procedure. If it is middle element is greater than search element, that means search element is small compared to middle element, then go to left hand side. That means middle element is here, this is the middle element. Middle element is more means remaining all elements are smaller. So go to right hand side. Our third point is if the middle element is more than search element, then go to, that means middle element is small, search element is more, then go to right hand side. So like this we can check it. Either middle element equal to search element or middle element is greater than search element. That means middle element is more, go to left hand side. If the middle element is small, then go to right hand side. So like this we can start your procedure. Through example I will explain. Here I will take some elements. These are the set of elements. And once again I will tell you, in the binary search all elements should be in the order. So here I will take the elements 3, 7, 9, 10, 12, all are in the ascending order. And then 25, 29 like this. So first I will take the array form. So first find the positions also. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 elements are there. So these are my 15 elements. So in this first, which element is there? That is known as low. And which element is here? That is called as high. So what is the position of here? Low equal to 1, high equal to, what is your high value? 15. So here low less than or equal to high condition, we have to check it. 1 less than or equal to 15. Yes, condition is true. Once the condition is true, we have to do, what we have to do? We calculate mid element. How can you calculate mid element? Mid element equal to low plus high by 2. So what is our low element? 1. What is our high element? 15. 1 plus 15 by 2. That is 16 by 2. That is called 8. So what is our middle element? Middle element is 8. Okay. Now we go for search element. Which search element is also known as key element. Which element you want to find? That is, for example, we think it is 42. Key element is 42. So search element is 42. What is your middle element? 8th position. So here check it. What is your mid element? A of 8. The 8th position, which element is there? 29. What is your search element? Search element is 42. So first point, either mid equal to search. Is it clear? Is it true? 29 is equals to 42? Wrong. So then compare. Which one is higher? Mid element or search element? So what is your middle element? Middle element is 29. Search element is 42. So 42 is more than your middle element is smaller and search element is more. So search element is more, means then go to right hand side. That means here middle element na. So from here we go to right hand side. That means not necessary to check it in the left hand side. That is called as divide and conquer. Depends upon the middle element. Now it is divided into two parts, left hand side and right hand side. So in the right hand side, what is the elements are there now? Again 31, 36, 42, 47, 53, 55, then 62. So this is the elements. Now check the algorithm. If search element is greater than middle element, yes, search element is more than middle element, then what we have to do? Low equal to mid plus 1. So what is our low value actually? Low value is 1. Here starting low value is 1, high value is 15. Now whenever we coming to here, low value is middle plus 1. What is our middle? Middle element is 8. So low value is now 9. 9 element is here. So this is now considered as low. This is 9th position. 9, 10, 11, 12, 13, 14, 15. Okay. Now it is low and high is nothing. No change here. So high is still 15 only. Low is 9 and high equal to 15. Again calculate mid. How to calculate mid again? Mid equal to low plus high by 2. What is our low value? 9 plus 15 by 2. 9 plus 15, how much? 15 plus 9. This is 24 by 2. 9 plus 15, 24 by 2. What is 2? That is 12. Okay. So, what is our middle element? 12th position. 12th position means mid element is now 47. But which element you want to search? Search element is 42. Again same thing. Mid equal to search? No. Again compare. Middle element is 47 and then search element is 42. So, which one is more? Middle element is more. If the middle element is more, then the elements is in the left hand side from here only. That means again it is divided into two parts. Here either right hand side or left hand side. So, which side have to go means check, it depends upon the value. The search element is smaller than middle element, go to left hand side. That means again we apply divide and conquer method. So, in this what is the parts again? 31, 36, 42, enough. So, what is the values of here again? It is in the 9th position, 10th position, 11th position. So, whenever middle element is more than search element, then we go to high value, have to change it. High equal to mid minus 1. So, what is high value? Low is nothing, no change. Low is 9 only. High value mid minus 1. So, what is our middle value? 12. 12 minus 1 means it coming to here 11. So, here L is equal to 9 only. Mid is now change it to 11. Okay, Nana? Again we have to do same procedure. Apply divide and conquer method again. Again we calculate mid. Low plus high means 9 plus 11 by 2. 9 plus 11 by 2 means 20. 20 by 2, that is 10. So, what is our 10th? Mid element is 10. Middle element means this one. So, middle element is 36. Search element is 42. Both are not same. So, again do it. Searching. That means middle element 36 is less than 42. That means middle element is small and search element is more. That means you go to right hand side. Right hand side means here only one element is there. Whenever here search element is smaller than middle element. Middle element is smaller than search element. So, whenever smaller than middle element is smaller than search element, go to right hand side, but check it. L value change it to middle plus 1. So, what is your middle plus 1? Middle value is 10. 10 plus 1, 11. Height we are not changed anything. So, here only. Here only one thing. Left is here and low value is here. High value both are same. So, again calculate mid. Mid is equals to 11 plus 11 by 2. That is 22 by 2. That is 11. So, what is our middle element? The middle element is 11. So, middle element is 11 means what is the 11th position? That is 42. Mid element is 42. What is our search element? Your search element is also 42. So, mid equal to search. So, 42 equal to 42. Then you are getting the element successfully in the 11th position. It is known as successful search. Binary search. See here, out of 15 iterations, 15 values are there. But 1, 2, 3, 4, within 4 searching, 4 iterations only we get that successful search. This is the main advantage of binary search. Binding and sorting, that is mostly there in Unit 5, programming for problem solving. So, in this searching and sorting, there are two topics are there. One is the searching and second one is the sorting. In the searching, there are two techniques are there. One is the linear search and second one is binary search. In the sorting, what is sorting and explain the sorting techniques using 3 methods. Those are bubble sort, selection sort and insertion sort. After that, order of complexity. So, these are explained in this topic. In this video, I will explain only searching. The next video will explain about sorting. So, first we will go for what is the searching. Searching is the process of finding some particular element in the list. First we take some elements group of elements. In the group of elements, find out particular element is available in the list or not. If the element is found in the particular list, then it called as successful search. Otherwise, if the element is not there in the list, then it is called as unsuccessful search. So this is the definition of a search. What is searching means? Searching is the process of finding some particular element in the list. Either it may be successful search or unsuccessful search. When we said it is a successful search means if the element is available in the list, present in the list. If the element is not available means it is called as unsuccessful search. Okay. Next, searching techniques. How many searching techniques we have means there are two types of searching techniques are there. One is the linear search and second one is the binary search. What is the difference between these two searches means? In the linear search, the elements are in any order. That means if it is a, the elements are not in the order, either it is in the ascending order or descending order, then also you want to find any particular element means then linear search is possible. If the elements are in the order, if we want to use binary search, the element should be in the order. Okay. Now, the linear search is also called as sequential search algorithm. In these two popular searching techniques, these two are. Linear search algorithm is also called as sequential search algorithm. Why it is sequential search algorithm means elements you have to find all the elements one after another. From the element 1 to we search one after another until you are finding the element. Okay. So that is the linear search element. In the linear search element, if you find out the particular element is available in the first element only, then not necessary to go to second element. Otherwise, you have to complete all the elements one after another until we get the element. Still last element also not finding me, that is called as unsuccessful search. So what is the time complexity of this linear search? Means the worst case time complexity of linear search is O of n, big O of n. That means you have to find what is n means n is the number of elements. If the element is not available, not there in the list means you have to search from the number 1 to last number. Okay. So then we will go for what is the algorithm of linear search. Algorithm of linear search. What is the algorithm of linear search? These are the algorithms. First start your process, then set position is equals to -1. This is the algorithm. This is the linear search numerical example. Now I am taking some elements from 0 to 8. That means totally 9 elements. Elements are not in the order. If the elements are not in the order, binary search is not at all working. We have to find out. We have to find the element through linear search only. Here my key element is 41. Key element k equal to 41 means I want to search particular element 41 is available in the list or not. So what is the procedure? How can you find the 41 is there in the list or not using linear search? Means in the linear search, I already said it is a sequential search. Sequential search means starting the algorithm from first element to until find out the element, you get the element or not. So first element, that is the because it is an array representation, all the array elements are starting from 0. So here totally 9 elements are there, means 0 to 8. So 0th element is 70. What is our searching element? The searching element is equals to 41. So compare your search element and first element. What is your first element? Your first element is 70. Which element we require? 41 we require. Compare 41 and 70, both are equal or not? Both are not equal. If the both are not equal, then we go to second element. Move the search pointer, move the cursor pointer to second place. So now I equal to 1. What is I equal to 1? What is the first position element? The first position element is 40. What is our key element? Our key element is 41. Compare again both the elements. 41 is not equal to 40. So then again go to third element. Like this we can search one after another. Next cursor point is moved to second place. The second element is 30, but our key element is 41. 41 and 30 is not equal. Then go to next element. The next element is 11. The 11 and 41 is not equal. Then move to next element, that is 57. 57 and 40 is not equal. Then go to next one, that is fifth position. And in the fifth position, the element is 41. Our search element is also 41. So 41 equal to 41. That means now the element is found. Then it find out the successful search. Where we get that element means it is in the position of 5. So the element is available at the fifth position. So this is the procedure for sequential search or linear search. Now I will explain a program for linear search. For in the linear search, what are the inputs we need? First we find out how many elements we need in the array. So that is explain, print how many elements we need, that is n. After that we have to take the elements into the array. For taking the elements into the array, we need for loop and then scan of ampersand a of I. So this is the size of the array and this is the elements in the array. After that we need which element you want to find, that is x. X is the searching element. So after taking the three elements, number of elements in the array, then searching element, we have to search from for loop I equal to 0 to n I plus plus. Then if a of I equal to x, this is the logic for finding a particular element in your list or not. If searching element and list element both are the same, then we write k equal to 1. Whenever both are the same, immediately exit from the loop. How can you exit from the loop? And that is called as break. If k equal to 1, then element is successfully searched at the particular index I. If the k is not equal to 1 means element is not at all found. So this is the program for linear search. After that, what is the time complexity of linear search? What is the meaning of time complexity? Means for finding any program, how can you find out the complexity of the program? Means either it is in the time wise or space wise. So for finding the element in the linear search, there are three cases. We are using time complexity. For finding time complexity, we need three cases. One is the best case, average case and worst case. Best case means the element is found in the beginning only, first element, first position only. That is called as best case. Average case means the element is found not in the beginning, middle of the elements. That is not in the first or not in the last. Between any these two places, if the element is found, that is called as average case. Worst case means either the element is found in the last position or totally it is not at all found. So that is called as worst case. See here, best case complexity means in linear search, best case occurs when the element we are finding is at the first position of the array only. So the best case time complex of linear search is big O of 1. 1 means because it is from the first step only, the first iteration only, are finding the element. That's why it is called as big O of 1. Average case complexity means it is in, we don't know where the element is found. So that's why it is called as O of n. Worst case means it is found at the end of the array. We are looking present at the end of the array, or the element is not at all there in the list also. How can you know the element is not there? Means compulsory have to find out up to the last element, then only we know the element is not there. That is called as worst case complex. That is also O of n. Okay. So this is the linear search complexity. Linear search time complexity. The space complexity is O of 1. Where the linear search is used. Searching in an unsorted array because the elements are not in the order. Then binary search is not at all possible to use. So in that case, you have to compulsory use linear search only. Next, implementing other algorithms. Linear search is often used as a subroutine in other algorithms. For writing bubble sort programs or selection sort programs or insertion sort programs, we implement these algorithms, we need linear search. Debugging. Linear search can be used to debug other algorithms and data structures by verifying correctness of the output. After writing any other algorithms, if you want to find out debugging of that particular programs, then we go to linear search only. When the size of the data set is small, so whenever the data set elements are less, then we go for linear search. So these four are the advantages of linear search also. So then what is next one is binary search algorithm. What is binary search algorithm means? Binary means 2. But binary search algorithm can be implemented only on the sorted array elements. If the elements are in the order, then we go for binary search. If the elements are not in the order, then first we have to sort the elements, then only it possible to binary search. Otherwise, binary search algorithm is not possible. So, but if the use difference between linear search and binary search means linear search, it takes number of iterations. Binary search means only half of the comparisons are reduced. I will explain how it is. See here. This is entire notes for linear search and binary search. We can easily read from this. But working of binary search. Binary search program is a go for either iterative method and recursive method. These notes I will post it in the video also. This entire thing is binary search. I will put one more notes in this video. Read this from binary search. See here. This is a working of binary search. What is the best case, average case and worst case of binary search means the best case is big O of 1, average case is O of log n, worst case is also O of log n. So in this video I will explain only binary search and linear search. This is a program for binary search program. So here first we take number of elements in the array, then we accept array elements. Then what is our searching element? After that, low element equal to 0, last high element equal to n minus 1. Then we calculate mid equal to low plus I by 2. So this is the program for binary search. Thank you for watching my video. If you like this video, share it to your friends. Thank you.